As we all know, the Earth is tilted, and this tilt allows for there to be seasons on our planet. The tilt of the Earth is exactly 23.5 degrees. If the tilt were less, the seasons would be less severe, and if there was no tilt, the seasons may not even exist at all. This tilt means that apart from 2 days in Earth's revolution of the Sun, these 2 days being the equinoxes, on any other given day in the revolution of the Sun, one of Earth's hemispheres or another is receiving more or less daylight than the other, because the axis points towards or away from the Sun at a slightly different angle each day, acting like a gradient from each season. Right now, we're going to focus on the north side of the axis, and this axis is tilted towards the Sun for part of the year, over here, and away from the Sun for part of the year, over here. Now, when the north end points towards the Sun, which is this case, the northern hemisphere has summer. Summer means that the days are longer, and the place involved receives more direct sunlight, which can be seen over here, because the majority of Earth's face pointing towards the Sun in this part of the year is on the northern hemisphere. And this allows for longer days and more direct sunlight. When the south end points towards the Sun, which is when the Earth is on this side of its orbit, the southern hemisphere has summer, for the same reasons as the northern, because the southern hemisphere receives more direct sunlight and longer days as a result. When neither end points towards the Sun, it is called an equinox, and usually means that night and day should last around the same amount of time each. These two equinoxes exist here and here, and in these two equinoxes, like I said, the night and day should last around the same amount of time. These are the only two situations when the Earth's axis isn't pointed towards or away from the Sun. Another reason as to why there are seasons on our planet is that different parts of Earth receive direct rays from the Sun at different times of the year. So, as the Earth revolves around the Sun at an angle of its axis being 23.5 degrees, the placement of the Sun's rays on Earth has to change drastically over the course of an Earth year, from this to about there, and then back, and back, and back. And it goes on like this, creating years. At the equator, as you can see, watch this line, the Sun's rays hit more or less the same throughout the whole year, meaning that the equator receives the most direct sunlight of any other place in the world. And as the Earth tilts, or not as the Earth tilts, but as the Earth moves around the Sun, its tilt causes direct sunlight to move over time. And so in June, you get a situation like this, where it is not winter in the north, but summer in the north. And this is caused because more direct sunlight, although our sunlight doesn't seem to be positioned properly here, but if it was, it would show that the direct sunlight hits the northern hemisphere of the Earth more directly with more concentration, as making the place more hot. And as the Earth rotates back to its position where it's winter in the north receives less direct sunlight, and the sunlight that it does get is spread out and less intense. And when it is winter in the north, the month tends to be around December, leading us to believe that different parts of Earth receive direct sunlight from the Sun at different times in the year. At different points in the year, however, the distance between the Earth and the Sun are also different, because the Earth's orbit around the Sun is elliptical, not a perfect circle. So, for example, at one point, the Earth might be X kilometers away from the Sun, and at another, it might be less than X kilometers away from the sun. Now, you may think that these changes in distance from the sun have something to do with the seasons. For example, being further away may mean less intensity. But in the scale, and when you put it in perspective, the relative distance from the sun compared to the relative distance from the sun to the earth, the distance is pretty small, and on that scale at least, and does not affect the seasons and the amount of daylight given. In the northern hemisphere, like the southern hemisphere, there are 4 seasons: winter, spring, summer, and autumn. Each of these seasons are the result of a combination between the hemisphere involved, the point in orbit, the tilt of the Earth, which is always the same, and of course the sun. Take summer in the northern hemisphere, for example. This season is caused when the Earth is at the point in its orbit when the sun in its orbit of the sun, where the northern axis points toward the sun, shown by this. Because more sunlight hits the northern hemisphere of the planet because more sunlight hits the northern hemisphere of the planet directly, it causes the place to become warmer as a result of concentration of the energy of the sun, and the fact that the energy isn't as spread out, which are both characteristics of the summer. Another characteristic of the summer is that the days are longer. This is caused by the tilt of the Earth in that moment, making it so that sunlight covers more than 50% of the northern hemisphere at any given point in summer in the northern hemisphere. For each season, there is a specific relationship between the hemisphere concerned and point in orbit around the sun that combine to create that season. Above was an example. Hopefully in this presentation we have explained to you why the different seasons occur on Earth. So thank you for being such a good audience.